Hello friends, in this video we study about some basic concepts in mathematical logics. I'll explain you about the atomic statements and some connectives and truth values of the connective. Also we'll find the truth values for compound statements. Now what is atomic statement? Atomic statement is any declarative sentence which is either true or false but not both. Declarative sentence means any statement, any sentence which declares something is called declarative sentence. There are possibility that the declaring sentence may have two truth value. True, sometimes it is true, sometimes it is false. But any sentence which is either true or false but not both is called atomic statement. For example, I'll give you some example for the atomic statements and some examples which are not atomic statement. Now we'll see example for atomic statements. First one, Canada is a country. That is true, right? Canada is a country. And second one, Mumbai is the capital of India. Mumbai is the capital of India. This statement is always false. We know our capital of India is New Delhi. New Delhi is the capital of India. But Mumbai is the capital of India. That statement is always false. So it is having only one truth value. Next, 1 plus 2 is equal to 5. 1 plus 2 is 3. That is not equal to 5. But it is given that 1 plus 2 is equal to 5. This statement is always false. This sentence is always false. Therefore, the sentence is atomic statement. And also, 2 plus 3 is equal to 1 plus 5. We know that 2 plus 3 is equal to 5. Also, 1 plus 4 is equal to 5. Both are equal. Therefore, this statement is true. It is having only one truth value, true. It is always true. Therefore, this sentence is atomic statement. So, any sentence declarative sentence which is having truth value true or false, but not both. Okay, that are atomic statements. Now we'll see example for statements which are not sentences which are not atomic. First one, what is your name? What is your name is not a declaring sentence. It is a question. So the sentence is not atomic. And even close the door. This is also not a declaring sentence. It is order. Next, x plus y is equal to 10. X plus y is equal to 10. We observe here x plus y is equal to 10. Now when x equal to 2, y equal to 8, this statement is true. X equal to 2, y equal to 8. What happens? 2 plus 8 is equal to 10. The statement is true. If I take other numbers, for example, x is equal to 1, y equal to 3. Then what happens? 1 plus 3 is equal to 10. Is the statement true? No, the statement is not true. 1 plus 3 equal to 4. It is not equal to 10. But the statement is true. The other one now which we took, that is false. So the sentence x plus y equal to 10 is having two truth value. At a time it is having two truth value. For different values of x and y, we are having different truth values. So the sentence x plus y equal to 10 is having two truth value. Therefore, the sentence is not atomic. And now, the statement is false. We don't know which statement it is. If the statement is mentioned, then we can identify its truth value. But here it is given, this statement is false. We don't know which statement it is. Therefore, the sentence is not atomic. We are not able to identify the truth value, or the truth value may be true or false. But without the statement, we are not able to identify its truth value. Therefore, the sentence is not atomic. Next, we study about some connectives. First connective is negation. What is negation? For any atomic statement, I'll take. Suppose P is one atomic statement and its negation. Actually, not P is the negation of any statement. Not P or sometimes did not. These are all. Negative of the statement is called negation of any atomic statement. And even we can write negation of the statement as it is not the case that P. If P is a statement, it is not the case that P. Suppose I'll take the statement P as today is Friday. Okay, today is Friday. I'll take the statement P. Then its negation is it is not the case that today is Friday. So, according to definition, negation of any statement is it is not the case that P. But actual negation meaning is it is negative of the given statement, opposite of the given statement. And negation is written as like this. If P is a statement, a negation of P will write like this. For statement P, negation, the symbol is negation, negation P. And we read this as not P. Now, truth value of the statement and negation. I'll consider a statement P. We don't know which statement it is. Atomic statement. Since it is an atomic statement, it is having the truth value either true or false. So the possible truth value for P is true or false. If P is true, then what is its negation? For example, today is Friday. If the statement is true, what is the negation of today is Friday? Today is not a Friday. Then truth value of the negation is false. Okay. If P is true, then not P. Negation of P is false. If P is false, negation is true. Next, we see some example for the negation. Suppose if I take the statement P as London is a city, then according to the definition, we can write not P or negation of P as it is not the case that London is a city. Before the sentence, we have to write it is not the case that. It is not the case that London is a city. One more way we can write like a usual negation, negative statement. London is not a city. London is not a city. This is also a negation, but this one is according to the definition. And even we can write opposite word for the negation. For example, here Q is given as he is rich. The statement Q is he is rich. Now, according to the definition, negation of Q can be written as it is not the case that he is rich. One negation is it is not the case that he is rich. Or else we can use the word not. How we can write? He is not rich. He is not rich. And even we can write its opposite. If he is not rich, he is poor. he is poor statement is also a negation of he is rich. Now the truth value, how I explain, P and not a P. If P is a statement, then negation of P. P is true, not P false. If P false, not P true. The truth value of negation and the statement is opposite. Next, connective conjunction. Conjunction means we connect two statements, atomic statements P and Q with the word and, or the connector and. We are combining P and Q with the connecting word and. Definition: let P and Q are two statements. The conjunction of P and Q is a statement P and Q. It is denoted using the symbol, conjunction symbol, P and Q. Example. For example, statement P is, it is raining today. And statement Q is, there are 20 tables in this room. Now we'll write P and Q, conjunction of P and Q, or P and Q. How to write the P and Q? We have to write write and in between two statements P and Q. What is P? It is raining today. After P, we have to write and. Next statement. There are 20 tables in this room. Okay. Now one more statement. R. Jack went to hill. Yes, Jill went to hill. Now R and yes. How to write R and S? See the following statement after Jack and Jill. Following statements are same. Went to hill, went to hill. So what we'll do? We'll write and between the word Jack, Jill. Okay, Jack and Jill went to hill. These two are the example for conjunction. Now the truth value of AND operator. Okay, AND operator is true if both the statements are true. We are applying AND operation or AND connective between two statements. Suppose P and Q are two statements. We apply AND operation between these two. Now conjunction is true. The entire P and Q is true if both P and Q are true. If both are true, then P and Q is true. If any one statement is false, either P or Q. If any one statement is false, then the entire P and Q is false. Okay. Now we will see the truth table. See. Since I have two statements P and Q, there are possibility that we don't know which statements are P and Q. Since they are atomic statement, they may be true or false. For example, there are cases we'll see. Maybe both are true. There are possibility that both 10 sentences may be true. Or first one true, second one false. Or first one false, second one true. Or the last chances both are false. Okay, no other possibilities of truth values of P and Q. Now, if both are true, I told when both the statements are true, conjunction is true. And second case, true, false. If any one statement is false, conjunction false. Here second one, Q is false, therefore conjunction false. We'll see the third case. Here P false, Q true, but one statement is false, therefore P and Q false. And last case, both are false, therefore P and Q is also false. Next, disjunction. Disjunction of P and Q. In disjunction, we write OR, word OR between P and Q. And the symbol is used to write the operator P or Q. Okay, let P and Q are the two statements. The disjunction of P and Q is a statement P or Q. and it is written as like this, P or Q. This one is P and Q. P or Q, just we have to change. P or Q. Now example. Okay, today is Friday. It is raining today. How we combine in disjunction P or Q? Today is Friday or it is raining today. Today is Friday or it is raining today. Next, two statement. Rose is red and rose is pink. So R or S can be written as rose is red or pink. Here both are rose. Rose is red, rose is pink. So rose is red or pink. Now the truth value of OR operator or connective. OR connective is true if any one of the statement is true. In P and Q, if any one statement is true, then OR operation is true. Both are false, then it is false. Now same P and Q, they are having four possibilities: true, 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 false, true, false, true, false, false. Now first case, both are true, so it is true. True, false. Here one statement is true, therefore true. Here also one statement true, true. Last case both are false, therefore answer is false. Next, what is compound statement? Compound statement is a statement which contains one or more statements. Statement means atomic statements. It may contain one, two, or many atomic statements, and it contains some connectives and statement. The combination of connective and statement is called compound statement. Here it is given. Statement which contains one or more atomic statements and some connectives are called compound statements or statement formula. These are the example. Not PC here. One statement and one connective is connected. P or Q, two statements and one connective. Here P and Q or not P. And connector or connector, not connector. Three connectors, P and Q, two statements. Here also P, Q statements and not are the connectives. Next we construct truth table for the following compound statements or statement formulas. P or operation with not Q. Okay, here how many statements are there? P and Q. First we'll write the possible truth values for P and Q. Both may be true, true, false, false, true, false, false. These are the four possible cases. Now, to find P or not Q, first we have to find not Q. We'll find not Q. What is not Q? Opposite truth value of Q. Here Q is true, so not Q false. Second case Q false, not Q true. Third case Q true, not Q false. Fourth case Q false, not Q true. Next we combine P and not Q. P and not Q with operator OR. And we know that OR operator is true if any one statement is true. Now here P true, not Q. We are applying OR operation between P and not Q. P true, not Q false. Therefore here one statement is true. P or not Q true. And next second case P true, Q true. Here also true. And third case P false, Q false, false. Both are false. That's why OR operator false. Fourth case false, true. One statement is true, so true. Next, P and not P. Here we have only one sentence P. Atomic statement P. P, only one statement. So possible cases, either it may be true or it may be false. If it is true, we have to find P and not P. So to get P and not P, first we have to find not P. We'll find not P. Not P is opposite of P. Here P true, not P Q. False. P false, not P true. Now we combine these two with AND operator. See, true and false. True and false. False. AND operator is false if any one statement is false. It is true only if both are true. And here also P true and not P false and not P true. False true, false. Both are false. Next, P or Q or not P. Here we have P and Q, two statements. So these are the possible truth values. Next we have to find P or Q or operation with not P. To find this, first we have to find P or Q. We'll find P or Q. When or operation is true, if any one statement is true or operation true. Here true, both are true, so true. Here one statement P true, so P or Q true. Third one Q true, therefore it is true. And here both are false, therefore P or Q is false. Next we find not P. What is not P? Negation of P. Opposite of P. Here P true, not P false. P true, not P false. P false, not P false. P false, not P true. Not P true. Next, we combine P or Q and not P with OR operator. Again, OR operator says that if any one statement is true, OR operation true. True, false, true. True, true, true. True, true, true. False, true, true. Next, negation of, not P and not Q. Here also two statement P and Q. So after that find not P, not Q. Then combine not P and not Q with AND operator here. False, false, false. False, true, false. True, false, false. True, true, true. Okay. Then take its negation. We got not P and not Q. Now we have to take this negation. So what happens? Opposite truth value. Here false, true. False, true. False, true. True, false. Next one. P and Q and P. Two statements P and Q. Q and P same. P and Q. After that you have to combine Q and P with the P using AND operator. Next, using the statements given below, R Mark is rich, H Mark is happy. Write the following in symbolic form. What is given? Mark is poor but happy. Mark is poor, but here R and H is given. Mark is rich and Mark is happy. And I forgot to tell that instead of and but are used in conjunction, but also have this truth value same as AND operator. Next, now first statement, Mark is poor but happy. But we know the letter for Mark is rich. Statement name Mark is rich, but here it is Mark is poor. Mark is poor statement is negation of Mark is rich. Mark is rich represented not R, so it's opposite, not R. Not R, but so we have to use conjunction and operator. Mark is happy, and happy means Mark is happy, so and H. Next, Mark is poor or unhappy. Mark is poor, same, not R. Or operator is this one, or unhappy. Happy is H, unhappy not H. Next, Mark is neither rich nor happy. Before writing this, understand the sentence. Mark is neither rich nor happy. Here we are not applying or operation. So understand the question carefully. Mark is neither rich, not rich, not happy. He is not rich as well as he is not happy. So Mark is not rich means not R and, because both, Mark is not rich, not happy. So and Mark is not happy means not H. Next, Mark is poor or he is both rich and unhappy. Mark is poor. Mark is poor means not R or operator, R and not H. What is R? Mark is rich and unhappy means not H. Next, given the truth values of P and Q as T means true. P and Q are true. Those of R and S are false. Find the truth values of the following. What is given? P or Q and R. Now we'll substitute the truth value. After that we can simplify the connectives. Here truth value of P is true. So everywhere instead of the term you substitute its truth value. True or Q and R. What is Q? True. And what is R? False. P and Q are true. R and S are false. Now, first we simplify the bracket. When AND operation is false, if any one statement is false, it is false. Now here, first one true, second one false. So it is false. Now we apply OR operation. True or false. And we know that OR operation is true if any one of the statement is true. Here, one statement is true, therefore entire statement is true. Next one, P and Q and R or not of P or Q and R or S. Now substitute the truth values, simplify. These are simplified answer. We know that truth value of P and Q are true, R and S are false, and negation of P and negation of Q are false, and negation of R and negation of S true. Okay. I hope you understood this explanation. In next class, we study about the other connectors, conditional and biconditional statement, and the truth table for the compound statement which contains conditional and biconditional connectives.